Hi, good evening. I'm Chip Corbin, the president, CEO, and also the inventor of this technology I'm going to show you today, which is I would call it the ultimate in hardware, with a little bit of a lot of a spin on energy efficiency. And what we're really dealing with here is a product that allows us to take what is out there. 60% of the U.S. is basically or motors out there are consuming energy. It's a huge percentage of the total energy being produced in the United States is actually being consumed by these motors. What Flux Drive's been able to do is take these motors and allow the output speed of whatever they're driving. In most cases, it's a blower, a pump, or it could be a gearbox, a conveyor system, and vary that speed of that particular system. The other alternative is to use some type of throttling valve or flow control device to regulate the output of that pump or blower. What happens is when we speed the system down or slow the system down with the use of the Flux Drive in between this motor and the blower or the motor and the pump, we save lots of energy. We can save up to 70% energy by slowing this system down. Why isn't everybody doing it? It just wasn't that big of a deal. Energy costs have been low, especially in the Seattle area, 4 or 5 cents a kilowatt hour energy costs. And people just did it the way they always did it. It was reliable for the most part. And now we are all really concerned about energy conservation and efficiency. So what I'm going to do now is I'm going to switch my mic here, hopefully. Can you hear me now? Okay. Get away from the other microphone. And I'm going to come over here and we're going to look at exactly what the Flux Drive is. So this component on the top of the demo device here is an actual electric motor. It's going to provide the torque, the speed. It's going to drive this can assembly, which is actually a magnet can. There's magnets in this can that populate the can through the thickness, and that in turn is going to spin this secondary rotor. So again, we have the motor itself is actually connected to the black internal rotor on this device. And then following that, the internal, we call it an induction rotor, is the magnetic can assembly itself. So the way we accomplish variable speed on this device is we actually can move the internal rotor, induction rotor, in and out of the magnetic can assembly. It's a fact of amount of magnetic flux that overlaps the actual induction rotor. So in this case, it's a manual actuator. I can push the rotor in and I can pull the rotor out. So what I'm going to demonstrate to you now is the effect of actually doing this when it's operating. So right now, the motor's running at 1 speed. The fan is barely blowing. And on this device here, I can actually show you, and I'll have to read it for you, but it's actually saying 420 watts is being consumed. Now if I speed up the device by pushing the rotor into the magnetic assembly, the fan starts blowing harder. Now I've got 665 watts of power. So I can almost get this right up to full speed. And at this full speed condition, we're actually running at 98.5% efficient, which is really where the Flux Drive shines and why it is such an alternative to other types of variable speed systems out there in the market today. And there are competition for us. They're called electronic drives. They do it differently. They'll actually slow the speed of the motor down and leave this connected without the Flux Drive in the middle, and they can change that speed. There's drawbacks to those type of products, and there's reliability problems. Those type of products are actually computer systems. The computer board, they typically have a 3 to 5 year life. The Flux Drive system, the magnets are magnetized for 10, 15,000 years. So there's no problem with that. The design life of the bearings of this product are 20 years plus on that. So we get away from all the maintenance associated with the electronic drives and replacing them. So we can actually sell this product on total cost of ownership or return on investment. The investment itself has typically been payback in less than 2 years. What's really neat about that is the utilities are sponsoring the program in their actual energy efficiency rebate programs. which are, at this point in time, every utility we've gone to with an energy-saving application where we can slow a pump or a blower down is subsidizing those installations with 70% grant money to pay for the total install cost of the systems. And that's happening from Tacoma Power, BC Hydro. It's also happening in the utilities in another installation we have is at the Columbus Zoo. And you know, it's been one of these programs that's been around for many, many years. It's not a government program. It's actually a rebate program from our actual energy costs that we pay for. So when we look at these applications, they're everywhere. This building's got blowers and fans, air handlers on every floor. There's pumps pumping chill water, cool water to those air handlers in the summer, or hot water to those air handlers in the winter. They can all be slowed down based on the actual demand of the space rather than regulated on valves or on dampers. So the opportunity just in the HVAC world is huge. The opportunity for pumping, we have irrigation, we've got marine applications. It's actually getting really exciting now. We're starting to see interest all over the spectrum. One of our more exciting opportunities right now is the U.S. Navy. They have a rather large energy efficiency program. We're submitting proposals now to develop the drive systems for those specific Navy applications. And we've even got other systems that are going to be growing. Right now, our production of the product is up to 60 horsepower. We have 200 horsepower units on the drawing board and actually being poured and cast and made as we speak. We hope to have those up and running and ready for purchase by July. And we've got one more client now who's actually looking for 1,500 horsepower drives. And we're going to go into a joint development with that company with a goal of producing that drive by the fall timeframe. It's going to be kind of exciting. It's a hovercraft project that'll propel a vessel at 70 knots, both lifted and thrust. There'll be 16 of the Flux drives on each vessel to pull this project off. It's a unique way of doing it again, getting away from variable speed engines. It's much more economical that way. So, you know, we've had great success. I really want to also thank our investors. From this past January, we closed our round and we went right into development and looking for applications. And so far, it's just been incredible, the interest all across the spectrum that we're receiving right now. And of course, we're selling what we have. And at this point, we've got 30 installations, and we expect the installations to grow. By the end of the summer, we should be surpassing 75, would be my guess at this point with what the pipeline looks like. That does not include what the Navy wants to do, nor what the hovercraft project wants to do, which will fall into next year. But that pretty much concludes what I wanted to demonstrate to you, and be happy to answer questions. Is that from the judges? Thank you.
So, does it work?
Yeah, there you go.
So, in an actual installation, what is it, you know, outside of this that controls the speeding up and slowing down? Is that a software thing that, you know, the building or what have you would already have in place?
Okay, I'm glad you asked that question. Excellent. I happen to have an actuator. Automatic actuator is going to be shown in this demonstration right now. What's going to happen is you can take a control signal. You're actually watching the yoke assembly, which is right here. You can see it moving back and forth. This is an electronic actuator. On the bottom, it takes a control signal. So when we just set it up to span the signal from 100% engagement, as it's moving in now, it's going to be going to full speed. And then as we're moving the actuator, so now the magnetic can, the induction rotor, full speed, 98.5% efficient, and then it'll slow back down again as it pulls the rotor back out of the drive. So that's how we do it.
Chip, what about, where will this not work because of the elements, like too much heat, cold air, rain?
Everything, it'll work in all those conditions. The colder it gets, the actual magnetism, the flux goes up. We're well within the constraints of any ambient temperature that we're going to see. And when it comes to salt water, chemicals, we're coating everything to take care of that. The Vancouver Aquarium actually has what they call diatomaceous earth, a powder that gets on everything, and we actually just hose it down with a hose. And as we have a video on the website, we say try that with your VFD or electronic drive. You're pretty much dead.
So you can hose those electric motors?
This is not a totally enclosed motor, but most of the industrial sites that are tough are completely enclosed. And that's the same with the actual bearing assemblies that are in the Flux drive. They're all enclosed, sealed bearings set up.
What's the cost on the installation?
Well, it varies with the size of the product line. What we've really been looking for is people look at it as compared to the electronic drives. So we're a little bit more expensive than the electronic drive is, but when we look at a 20-year payback period, you're going to replace those drives 3 times compared to our drive that's going to be serviceable for life. So that's the best way I can describe it. You know, in the smaller sizes, you're probably looking at a cost point of about $10,000 that we sell to our distributors, and they mark up from there. If the payback to the utility gets less than 2 years, they start to say, why should we subsidize it? You should just do it because the payback is so good. So that's made our price points really work out well and given our distributors a different way of selling on the return on the investment rather than the absolute cost compared to the electronic drives.
So along those lines, can you talk about the typical ROI for a customer? Sorry, typical ROI from a customer
They're looking
perspective.
at it anywhere from 1.5 years to 3 years in that time. If you look at it compared to like a solar investment or some of these, they're talking long-term investments, 10 to 15 years. So these are just totally make sense for the customers to switch to this type of technology. And many of them have had problems with the electronic drives, and they're replacing them and replacing them and replacing them.
Is this a one size, one mechanical design, one packaging for all application kind of product, or do you like a custom tooling and?
There's a range, and the range follows what they call the frame size of the motor itself. So, for instance, our magnet can be populated with different amounts of magnet in that. So I can make a can assembly that could take you from 5 horsepower to 15 horsepower. Another one will go from 15 to 30. Another size will go from 30 to 60. So you don't have as many model numbers that you need within those ranges, and then put more magnet material in or less based on what the application is and what the power requirements are. So we get a lot of part sharing, and we have done a lot of effort to consolidate parts. So we have as few parts as we need, taking advantage of casting and precision machining. And we have incredible shops in the area that I don't have time to list them all, but it's just really incredible the help we've had.
Where are they manufactured, and how quickly can you scale up your manufacturing?
Yeah, the manufacturing's from Marysville to down in Frederickston. Essentially, everybody's in that area. All the parts are assembled right now in our shop. As the product scales, we'll team up with other manufacturing companies and machine shops that can help us do that. Products are going to get very large. A 1,500 horsepower drive is going to be in the order of 2,500 pounds. We just don't have the overhead cranes yet, so we'll team up with these other businesses. And that's really been key to our success, has been teaming with the machine shops, and we've been learning the best way to make everything at the least cost. So it's a huge amount of experience in the valley here. It's incredible. Okay, thank you.
Other questions?
I have a question for the Flux motor. So I'm familiar with magnet drive, and I know one of magnet drive's problems was that the magnets that they were getting were pretty much from China, made with rare earth metals, and the supply chain was really quite problematic because it turns out that the only place in the world to actually get that stuff is from China. So how have you secured your supply chain to be able to accommodate the kind of growth that you would hope to find?
Yeah, there's been a lot written about the rare earth magnet availability. To this point, the suppliers we're utilizing, and one of our investors is a Singaporean Chinese. He's actually helped us identify the most reliable groups in this rare earth area. And we really haven't had any of these problems to date in the size ranges of the magnets we're looking for. And we're actually ordering and receiving the magnets within 30 days of the time. The other aspect of the rare earth products out there, or magnets material, is since they have kind of driven up the price, the availability of the product has gone down. Now more mines are opening up throughout the world. So you got Australia coming online. The U.S. may actually start producing the material again. So I think all that's just going to kind of moderate this little bit of a blip in the price. For us, it only ends up being about 5% of the cost of an entire drive system as the magnet cost, since we're really efficient on the amount of magnet material we need to use.